Good morning students. So today we are continuing with the first chemistry chapter, which is matter in our surrounding. Clear? So in this chapter you will learn about the different matters. Okay, so let's understand the first what is matter. Okay, so matter, the definition of matter is what? Matter is mean material. Okay, so definition of matter is what? The anything, matter is anything which occupied a space. For example, suppose you are going to fill water in a glass, water particles in a glass. So water is required some space. So in the glass, what is the matter? The matter is water. Means matter is a thing, matter is anything which occupies a space. Clear? Suppose you have blood in your bodies. Okay, so blood will occupy some shape, some area of a body. Na? Blood will having some area, blood will acquire some area of your body. Okay, so by which we can say that the matter occupied by a body is a blood. Clear? So matter is anything which occupies a space, which needs a space. Okay, so in this chapter the various classification of the matters are solid, liquid and gases. So we have to learn about the various phenomena, various properties and speciality of these matters. Okay, so shall we start? Fine. See, first here, when this is the solid, this is the liquid and this is the gas. As you all know that in a solid, for example, the brick is there, a brick. Okay, a brick is there. See, in the brick will be a solid material. So when we microscope, when I am using microscope, I will see the structure of the brick. So all the atoms of brick, means the tiny atoms which are available in the brick, are very closely attached to each other, very close, very tightly packed to each other in the form of brick. Means what happened in the solid substances? Okay, in the solid substances, the particles of matter are very closely spaced to each other. Clear? In the liquid, so let's have the example of liquid. See, liquid like a water. So water, when we pour a water in any kind of utensils, in any kind of pot, the water will acquire that shape of that kind, because in the water particles, in the liquids, the particles are in such a way that they are loosely attached to each other, means they having some gap between them. Clear? And this third thing, in case of gases, in the gases the particles are arranged very far to each other. Okay, like random in a manner. Okay, so that's why they having not definite shape. Clear? So in the solid particles, the particles are very near, in the particles are very far, almost far, and in this case the particles are very far to each other. Clear? So from this phenomena we can say that in the solid there is no gap, in the liquid there is some kind of gap is found, in the gases and there is too much gap found in the space of between different molecules. See in this figure, can I zoom this figure? See in this, see, in case of solid, very small distances will be found between the different particles, but in case of liquid there is some more space compared to the solid will found between this, and the gases lots of space are available between the molecules. So the first property tells about that the particles are varying, and they have space between them. Means as the particles are varying, as the particles moving from the solid to liquid to gas, the space between the particles is varying, the space between particles are continuously changing. Okay, in the solid case the particles are very near, in the case of liquid the particles are far, in the case of gas the particles are very far. Means as the particles is varying, as the particles are taking, as the matter is changing their shape. Okay, the space between them is also varying, the space between them is also changing continuously. Understood? Okay, so here the definition of matter is given. So from definition we can conclude that the matter is a material of which everything in the universe which around made up different shapes, it anything they occupy space and mass. Okay, so a matter is anything in the space which occupies a mass. Clear? And the matter is made up of materials. For example, I already told you the brick is made up of the very tiny particles. very small particles are there. Okay, so the matter is made up on particles, and the particles are very small. The particles are very small. And from the second property we can say that the particles having some kind of space between them. Either the space will be a very less, normal, and the large. Clear? The particles having space between them. Clear? So now there are some particles. See, characteristics of particles. So first property, the particles are matter are continuously moving. Clear? Means, see, this is the ice. Okay, ice. Suppose I am going to heat up the ice. So ice will convert to the water, and I am again heating the water is converted to the gas. Clear? So means particles of matter are continuously moving. Either in case of any energy they are getting from the outside. For example, they possess kinetic energy. As the temperature rises, okay, particles moving faster. Mean in case of solid, the particles are gaining energy, so particles are moving very faster. Again I am supplying the heat, the particles are again moving very faster, so they will convert solid to liquid and liquid to gas. Clear? So the particles are continuously moving, but they require certain kind of energy. Clear? And particle possesses kinetic energy between them. Clear? Particle of matter has space between them. I already told you. Okay, any particles in this universe, either solid, liquid or gas, having some kind of gap, the gap will be very less, average, or the very far. So every particle will occupy a space between different two individual molecules. Clear? And particles of matter are attract to each other. Clear? Means, see, whenever you are going to open a tap, okay, a tap, okay, so tap flowing the water, means what happen in this case, all the water particles are attracted to each other. Clear? So the example is given, when we open a tap, break the stream or water your fingers, they no just stream of water maintained together, the particles of water are held together because of force of attraction between them. So the particles are attracting to each other. That's why in this case of solid, the particles are very near to each other. In case of liquid, the particles are loosely bound. Okay, in case of gas, the particles are not bound that much with the help of that much energy, so they are very far to each other. Okay, so see, the space between the particles and kinetic energy particles in the immediate liquid and maximum in the gases. See, the space is very higher in the solid than liquid than gas. Clear? The force of attraction, again the force of attraction in case of solid very higher, liquid come less to gases, and the movement of particles in case of solid is very restricted, in case of liquid is somewhat restricted, in case of very fast. Clear? In gas of the movement of particle very high, in liquid the movement of particle is low compared to the gas, in the solid the movement of particle will not allowed. Okay, but the force of attraction in case of solid is higher from the liquid, and liquid higher from the gases, and the space between the matters, solid having the very less space, liquid having very a normal space, and the gas having very large space. Clear? Now the next topic, states of matter. So as we already discussed, there are three states of matter, either solid, liquid and gas. Clear? Okay, so we are classified this something kind. So let's understand the property of different particles individually. Clear? In a solid state, the first comes will be the solid state. In the solid state, so as we all know that when the particles are arranged very close to each other, so they having certain kind of shape, either brick, either wall, anything. So the particles having a definite shape, so due to the very much attraction between the particles. Okay, they having the boundaries, because the solid having the boundaries, the solid having range up to here, then we can say it is up to here, right? And we can't press the solid, and we can't disclose the molecules without having any high force. So they having the incompressibility, they are not pressed. Clear? And they having the definite volume. Clear? So there are some examples. So rubber band is solid, but it can change a shape and regain the force it is removed. Clear? The solid have fixed region, shape, fixed boundary, and the kinetic energy of particles is very less. Clear? Because the particles are not able to move. Okay, and we compress the solid, so this having the less compressibility. But in case of sponge, the sponges, when we compressing the sponge in the water, so sponge having the pores will fill with the water. Okay, sugar and salt lake, shape of the container they will place, shape of the crystal do not change. Say they are solids? No, they are not solid, they are the liquids. Clear? The second state, the liquid. As we know that the liquid having some space between the particles, clear? So due to these particles, they having the ability to flow, so have fluidity, they can flow. Okay, they are not, they having not definite shape. Okay, they having not definite shape, no boundaries. Okay, but they can take a shape of vessels. In any vessel you pour the liquid, it will take a shape itself. Okay, and they having the definite volume, clear? Fine. And the force of attraction between the solid particles is lower compared to the solid, and liquids are substance having the fixed dependent shape and volume. Okay, and the next is the gases. So you know that in the gas particle, the particles are very far to each other, clear? So they having compressibility, they having not definite shape, they having fluidity, yes, they having high compressibility because we compress the gas. Okay, they have no boundaries, they have not definite shape, and they have no volume, clear? The particles and gas are free to move because the kinetic energy of solid is very high, clear? So in case of gases, the particles are moved very far to each other, very highly to each other, clear? So here the first portion of the states of matter is